Hi everyone. In this video I'm going to discuss how you can use Many-Facet Rasch Measurement for psychometrically validating peer assessments in your classes. If you are a teacher, at some point you might want to engage your students in peer assessments, and that indicates that you want to figure out whether students can evaluate each other's performance in a psychometrically reliable way or not. So the fact that some student provides some feedback or scores on another student's performance does not necessarily mean that that feedback is going to be very useful or it's going to be reliable. So in my opinion, if you're a teacher, the first step to ascertain that the feedback is useful is to look into the psychometric attributes of the feedback, if the feedback is in a quantitative format. Now, the feedback that I have collected today from a group of students who are enrolled in a graduate program includes this data sheet. The name of the students and raters are masked and they have been replaced by IDs, but we know who these students are in other sheets here. As you see right at the bottom, we do have their information and their names. Now, every student has been rated by a number of raters. So altogether we have 13 students who performed who played the role of a rater and also a presenter. Every presentation was about 5 minutes long, and it was video recorded, and the links were circulated among the students. So today I think it was a very busy day for all the students because they did both presentation and rating. The evaluation form that we used was a shortened or abridged version of another evaluation form which was validated in an earlier study. I will provide the link to that earlier study in the comments section for you, just in case you are interested to see what's going on. So the rating scale had 15 items in the present study, and the scoring category ranged from 1 to 4, 1 being the lowest score and 4 being the highest score. And as you see, just by eyeballing the scores here, you can see all sort of scores: 3, 4, 2, and in some cases quite a few ones like this one and that one. So we have a large number of data here, and it's important for us to make sense of this data before we send it out to students. So let's get started with this. I have already transformed the data into a sort of format which will be suitable and ready for Many-Facet Rasch analysis. I have discussed how to create this input file in another video. If you haven't watched that video, I will provide the link in the comments section for you. I suggest that you take a look at that video. I have 3 facets here. One of them is student. That's the first facet which I showed you, and that's how I've arranged it. Student is the first facet. The second one is rater, and that's the rater. And the third one is items 1 to 15. And if you have not watched the previous video, and if you want to quickly know what a facet is, actually a facet is anything that can affect the score, the final score of the student. In this case, the student ability, that's the most important facet for us. But we also know that rater severity or leniency can also affect the score of the student. So that's why we need to include rater and also items. That's the difficulty level of the items can affect the score that the student will achieve. And the rest of the story is data equals, and I've just copied and pasted this portion of the sheet all the way down and pasted it here. Okay, so I'm going to close this. This one is open too. So I'm going to close this and minimize this and run the analysis. I have the latest version of facets. Let me see what version it is. It's version 3.83.3. So what I'm going to do is really just to drag and drop it into facets software, and this pop-up window appears on your screen. I click OK, and it's asking me if I want to change the file name. No, I'm not going to change the output name, so I'm just going to click open, and we'll wait for the results. This is iteration. Iteration basically is necessary to estimate the parameters. And in this analysis, the parameter, there are three parameters, three groups of parameters: student ability parameters, then rater severity parameters, and also item difficulty parameters. So these are the iterations. There are 28 iterations, which is pretty good. It's not when there are not too many iterations, it's relatively good news for us. So the first thing that I would like to look at is what is known as the Wright map after Benjamin Wright, because Benjamin Wright and Mike Lineker developed this map. So the first facet is students, and I think this map is really very useful. As you see, the highest score on average was achieved by student number 5, and at the same time, let me see, the lowest score was achieved by student number 10. So and this line here on the most left hand side is like a ruler with the mean or the average score of 0, and we have got units. So it's like, let's say it's like 1 centimeter from 0. That's 1 logit. I say centimeter because that's like an analogy which might be more accessible. So between 0 and 1, there are 3 students. This is their ability level, based on their ability level. Between 1 and 2, there are quite a few other students, and between 2 and 3, there are 3 other students. So I think it would be probably just based on, of course I have looked at the results earlier, but just to give you a kind of heads up before we look at the results, I would say there are these 3 groups or clusters of students can be put into 3 separate groups: cluster 1, cluster 2, and cluster 3. So we have 3 clusters of students, more or less of the same ability level. Now for raters, the story is different, a little bit different. Let me see how we can. Okay, so for raters, we have a little bit of a different story because we have rater number 7, who is right at the bottom. This scale indicates rater severity. So if you are on top of the scale, it means that you have a higher severity level. And if you are at the bottom, it indicates that you have a lower kind of severity. In other words, this rater on average gave less or lower scores than this rater on top. So imagine that you have a teacher who is more severe, like number 7, compared with a teacher who is more lenient, like number 8. Well, thanks to the possibilities and affordances of facets, it's possible to estimate the severity of raters and then take it away from the scores of the students. So the scores of the students will become fair scores in the sense that they're not affected mathematically by the severity level of the raters. Okay, so we may be able to also identify maybe 3 levels of severity among our raters. Let me just choose a different color here. Maybe this is the first level, just guessing. Really, it may not be reliable. Maybe this is the second level, and maybe this is the third level. Altogether, just by eyeballing this map, I'd assume that there are maybe 3 levels of severity among our raters, but we can actually check later. And finally, items that were used, there were 15 of them. As you see, number 13 is the most difficult one. That's the most difficult to achieve a high score on. And number 4 is the easiest one. That's the easiest to achieve a high score on. So it seems that there might be 2 or 3 levels of difficulty among the items as well. Overall, well, yeah, sorry, I have to keep pausing this video because my neighborhood gets a bit noisy and I don't want to capture the noise in the video because it could be quite distracting. So yeah, I was saying that overall the distribution of students right here, let me just show that by drawing some lines around it for you. This is the general distribution of the students. If you compare this distribution of the students with that of the raters, you'll see that the distribution of students is above that of the raters, and also the distribution of items is more or less also below the distribution of students, which means that on average students are more able than the items, which means that they have received high scores on the items on average. And also the severity of the raters actually it's basically more than this, so I have to drag it all the way down to include this rater at the bottom as well. So as you see, there is a larger spread of the distribution of the ability of the severity of the raters than the spread of student ability. And the spread of items and the difficulty of items and students is the same, but almost the same. However, with regards to their level, you see the items on average are lower than the average of the students here. So that's another thing to take into account. Okay, so let me just pause this video and continue in the second video. Thanks for your attention.